Hey, I'm David,
I'm Joel.
and this is a Bombardier jet ski. It weighs roughly 600 pounds and is resting on a metal bed, give or take 400 pounds. And we need to lift it up. The way we're going to lift it up is by using this.
So this here is a hydraulic trolley jack. So if we see internally, this is pumped by this lever here via a smaller cylinder and to a larger cylinder.
Alright, so while Joel is setting up the hydraulic jack, I'm going to do a brief overview of the purpose of this lab. So what we're trying to find is how much energy is exerted by the hydraulic jack per pump.
So the way we're going to figure that out is by having this reference point here. You can see this tape here. And then every pump, we're going to determine the new height of this tape.
Okay, so this is an explanation about what happened in our experiment. Here we have the jet ski and the metal bed it rested upon. As you can see, the metal bed had two main supports, the back wheels and the front wheels. Although in reality the weight wouldn't be equally distributed, we will take it as though it were, since it would be too complicated to figure out exactly how the weight was distributed. So the total combination of their weight came out to be about 1,000 pounds. In kilograms, it was 453.592 kilograms. We found this out using simple conversion and researching the model of the jet ski and of the metal bed. So after we figured that out, we decided to, we realized that the hydraulic jack, there was no point in the metal bed that it could be placed where it would pick up the whole system. So we decided to have two reference points. One where we would place the hydraulic jack, which would be next to the back support, and the other being the front support. So once we figured out the reference points, we decided to measure the height from the ground. And the height of the back reference point was 37.7 centimeters, and the height of the front reference point was 39.6 centimeters. The reason why there is a difference in height between these two reference points was because the ground was not level. It was a bit slanted, and we wanted the bed to be as level as possible, so we adjusted for that just to make sure that we start off with a 0-degree angle. And so from there we just placed a hydraulic jack on the first reference point, and we pumped it, and slowly but surely it started pushing the whole thing up, reaching a maximum height off the ground of 45.5 centimeters. We compared that to the initial height that we recorded earlier, and we got a total displacement of 7.8 centimeters. Just to make sure that the second reference point, the one in the front, did not change in elevation, we measured it again, and surely enough, there was zero displacement on that part. From there, we measured the distance between the reference points, the horizontal distance at least, and that came out to be 213.4 centimeters. As I mentioned earlier, just to make it easy on calculations, we treated this as though it was an equally distributed load, and with there being the two supports, R1 being the hydraulic jack and R2 being the front wheel, the reference point right there, and the total force that they had to counteract was the mass and the gravity of the whole system. That came out to be 4,445.2016 newtons, and we decided to distribute that equally among both loads and gave it to be 2,222.6008 newtons for each support. Just to see how the angle that was produced, as it was raised to the maximum displacement, we calculated that, and we got the displacement, we got the distance between the two reference points, we got the angle based on the tangent, and that came out to be 2.09 degrees, which is a fairly small angle. And surely enough, the difference between whether or not we included that angle was about 1.5 newtons. And we just decided to not include it in the report. And to get the energy, we needed the force and the distance. We used a bigger force, and to get the distance, we needed the maximum displacement, and we converted it from centimeters to meters. We got 0.078 meters. That came out to be 173.36 joules. We did about 42 pumps with the hydraulic jack. So we divided the total energy by 42, and we got an average of 4.13 joules per pump.